I'm going to do my homework problem number 1 of third homework. In this, we're supposed to find the value of b, constant b. We know that when we're going to do the for capital P of x is equal to k, when we do the integration of this is equal to 1, summation of this is equal to 1. Therefore, when we do this, we get this sigma k, summation of k from k is equal to 1 to infinity, k times p of k minus 1 into b is equal to 1. We know that this particular part is a GP. Therefore, the sum of GP of infinite terms in this particular format is b into 1 minus p to the power of minus 2 is equal to 1. Therefore, b is equal to 1 minus p to the whole to the power of 2. Moving on to second question, that is finding E of x. Sigma, that is k times p of x equal to k. Therefore, k into b of k p to the power of k minus 1. Here b is 1 minus p to the power whole minus 2. So k square 1 minus p whole to the power 2, p into k minus 1. We can remove this 1 minus p to the power of 2 outside of the summation. So summation k square p to the power of k minus 1. What happens here is when we do this, we end up with this equation p plus 1 by 1 minus p whole to the power of q. This and this get cancelled, and we end up with p plus 1 by 1 minus p as the value of E of x. In order to find E of x square, what we do is we multiply k square with p of x equal to k. That eventually leads to k square into b k whole to the power of k p to the power of k minus 1. This part k cube p to the power of k minus 1 is p square, this function. When we expand this k cube p to the power of k minus 1, we end up with this function. That into b is we have found out that b is value is 1 minus p to the power of 2. That is therefore e to the power of x square is equal to 1 minus p to the power of 2 into this function. Moving on to question number 3. We have to find the value of E of x square minus E square of x. E of x square and E of x whole to the power of 2. Simply substituting the values of E of x square and taking a square of E of x will provide us the value of this. We know E of x square value from this. I'm just going to substitute that over here, and E of x is p plus 1 by 1 minus p. I'm squaring that, the p plus 1 whole square by 1 minus p whole square. Substituting the value of this will provide the value of E of x square minus E of x whole square. Now moving on to question number 4, we have been given that p is equal to 1 by 3, and we need to find p of x equal to k when x is in the interval of 2 and 5. By using the formula of conditional probability, we get p of x equal to k by p of 2 when x is in between 2 and 5. The value, the output of when p of x is equal to k is this one, where we substitute the value of p minus 1 whole to the power of 2, k into p to the power of k minus 1 by same thing, k into p. But here the summation is from 2 to 5, and here it's 1 to infinity. Now we are going to solve the denominator. When we solve the denominator, we substitute the value of p as 1 by 3, and we open the brackets over here. What happens is we substitute the values of k from 2, so it's 2 to the power of 2 into p to the power of 2 minus 1 plus 3 into p to the power of 3 minus 1, and so on. We eventually end up with 2 into 1 by 3 plus 3 into 1 by 3 square, and so on. Solving this whole thing will provide a value 320 by 729. That is the numerator. The answer is 1 by that, and that is 729 by 320.